So this question says quadrilaterals PQRS and WXYZ are similar. So I don't know what type of quadrilateral this is. I'm going to just draw it as a rectangle. It could be wrong. So again, I'm using plug in picture as my strategy, and it's okay to be wrong, right? I can just redraw it if I'm wrong. So quadrilateral PQRS, going to go around in that way, and WXYZ, going to go around and label it the exact same order, are similar, where PQ and R correspond to WX and Y, which we see. The measure of angle S is 135. All right, so then obviously it's not a rectangle because those angles would be 90 degrees, but we can maybe still get away with this. So 135 is there, which means, by the way, that Z has to be 135. Like that's what it means to have similar shapes. So those corresponding angles have to be equal. And then it tells us that PS is 45. So this is 45. And WZ is 9. All right, well, that tells us that the parallelogram WXYZ is 1/5 the size of the parallelogram PQRS. Or another way to think of it is parallelogram PQRS, or I'm sorry, quadrilateral PQRS is 5 times the size as quadrilateral WXYZ. So that's very helpful. So WZ is 9. What is the measure of angle Z? Oh, so trick question. The angles are all between two similar shapes are always congruent. Their side lengths are proportional, right? So again, 9 and 45. If I told you this was, say I told you this was 55, that would make this 11. So we can use the proportionality of their side lengths in that way. But when it comes to the corresponding angles, their corresponding angles are always equal. So angle S and angle Z must both be the same, and that is 135 degrees. So actually, this question is not too bad at all. Choice D is the correct answer here.